A good day everyone. For this lesson, we're going to talk about the concept of truth tables, tautology, contradiction, and contingency. So our objective is to construct the proper truth table of the given compound propositions and determine if or classify if they are tautology, contingency, and contradiction. So first, let us define the truth table. So truth table shows the truth value of one or more compound propositions for every possible combination of truth values of the propositions making up the compound ones. Here, we have to provide the two formulas to construct the appropriate table. Let's say we have a variable small letter n. N represents the number of simple propositions provided that it is not negated. Then, there are 2 raised to n rows and 2 raised to n minus 1 number of t's and number of f's for each simple proposition column. Now, to understand this, let us recall the 4 logical connectives and their respective truth tables. Here we have the conjunction, disjunction, conditional, and biconditional. Now, we're going to apply these truth tables in order for us to construct another random compound proposition. So, the truth tables of random compound propositions. Let's have an example. Let P and Q be any propositions. Construct a truth table for sentential form, not P, conjunction of P implies Q. Here, the number of simple propositions are 2. We have 2 raised to n. As I said earlier, this is the formula to determine the number of rows. And since n is 2, we have to substitute 2 from variable n. That's why we have 2 raised to 2, which is 4. On that case, we found out that the number of rows is 4. Now, number of t's and f's. The number of t's and f's can be represented as this formula, 2 to the power of n minus 1 equals 2. We all know that n is 2. That's why we have 2 raised to 2 minus 1 equals 2 raised to 1 or simply 2. That means we have 2 t's and 2 f's. Now, on this table, as you can see, the first 2 columns is automatically P and Q. Then, to determine the 3 column headers, let us try to analyze what are the other involved sentential forms. Now, here, this is the given. We have a portion of not P. Okay, this is not P. That's why we have to provide not P as a column header. Next is conditional form within the parentheses, that is the P implies Q. And we need that sentential form for this column. And the last vacant position is for the entire given proposition, which is the not P conjunction P implies Q. Now, we are ready to place all the possible combinations of T's and F's. So, dito, we have 2 T's and 2 F's. Gaya ng sabi natin sa number of T's and number of F's. And 2 plus 2, that is the total number of rows, which is 4. Now, for column Q, check nyo mabuti na yung alternate positioning ng ating T's and F's. We have TF, TF. To recognize the truth values under the column of not P, let us get the exact opposite of the proposition P. Since we have TT, here we can write FF. And over here, we have FF. The exact opposite is T and T. Now, for P implies Q, let us apply the biconditional law. T implies T is true. T implies F is false. F implies T is true. And lastly, F implies F true. For the last column, check the column of not P and P implies Q. They are conjuncted. So we have to apply the conjunction law. Okay. F conjunction T, that will be false. F conjunction F, false. T conjunction T, true. And same reasoning, true. And that's it. We're done. Let's have another proposition or sentential form. Now, we have three pieces. Simple propositions P, Q, and R. That means the value of n is 3. Now, to apply the given formula, number of rows, 2 raised to n, where n is 3. That's why the number of rows is 8. Number of t's and f's, that will be 2 to the power of n minus 1. And eventually, it will yield into 2 raised to 2, which is 4. So we have 4 t's and 4 f's. 4 plus 4, that will be 8. Now, to construct the truth table, let us first write the column headers P, Q, and R. Observe that the next column header is P disjunction Q. Nakuha yan dito sa part na to. Then, this entire quantity or entire compound proposition P disjunction Q disjunction R. Next po, Q disjunction R and P disjunction Q disjunction R, and the entire compound proposition, which is yung P disjunction Q disjunction R if and only if P disjunction Q disjunction R. Now, observe that the hierarchy of T's and F's for each simple propositions P, Q, and R, we are doing this to avoid duplicates. Here in P disjunction Q, let us focus on columns P and Q and apply the disjunction law. T disjunction T is true. T disjunction F is also true. F disjunction T, true. And lastly, F disjunction F, false. Now, to obtain the truth values for this column, let us focus on P disjunction Q and R columns. T disjunction T, true. T disjunction F, true. Same reasoning. And T disjunction F or F disjunction T is also true, except for F disjunction F, which is false. Q disjunction R. TT, true. TF, true. FT, true. FF, false. And same reasoning. Let's have P disjunction of Q disjunction R. T disjunction T, true. Same reasoning. F disjunction T, that will be true. T disjunction F, true. Same reasoning. And lastly, F disjunction F, which is false. Now, for the last column, this is the combination of this column and this column. Observe that we have a biconditional form. So, we all know that in biconditional form, true lang siya if both antecedent and conclusion part are true or both are false. As you can see, T and T in biconditional form, that is true. F and F, that is also true. Notice that the last column contains T's. No? They are purely T's. And this truth table is what you call the tautology. So, tautology is a statement whose truth value is always true. Let's have another example. Consider the sentential form P implies Q, conjunction of P conjuncts negation of Q. Here, we have two pieces of simple propositions. Those are P and Q. So, the hierarchy will become TTFF and TFTF. This portion is P implies Q. We have a negation of Q. That's why we have to put this into our next column. Next is the conjunction of P and not Q. And lastly, the entire sentential form. P implies Q. T implies T is true. T implies F is false. F implies T is true. F implies F is true. Negation of Q, let us get the exact opposite of this column. We have FT, FT. Next, let us emphasize the columns P and not Q. And then let us use the conjunction TF, F. TT, true. FF, false. FT, false. And last column na po tayo, class. This one and this one. Let us use the conjunction once again. TF, F. FT, F. TF, F. TF, F. All cells under this column contains an F as a truth value. That means we can consider this as your contradiction. Now, the contradiction is a statement whose truth value is always false. Let's have our last example. Consider the sentential form P if and only if Q, conjunction of not P implies not Q. We have two simple propositions. Originally, those are P and Q. So, same lang ang ating hierarchy. TTFF, TFTF. We have this portion. That's why we have P if and only if Q. Next, we have not Q. That's why we have to put not Q on this column. Next po is this compound proposition P implies not Q. Next one, we can insert this entire guy. Not P implies not Q. And the entire given compound proposition. For this column, let's have the biconditional form. TT, that's true. TF, F. FT, F. Then FF, true. Not Q, exact opposite of this column. FT, FT. P implies not Q. So let's have this one and this one. T implies F is F. T implies T is T. F implies F, T. F implies T, T. Next, let us negate this column. Okay. Negate. TF, F, F. Next, yung huli natin, class, P if and only if Q, then we will conjunct this to this column. T, conjunction T, true. F, conjunction F, F. Same reasoning. And lastly, T conjunction F, F. Observe that the last column contains a combination of true and false. We have 3 pieces of F and 1 piece of T. On that case, we can consider this as neither tautology nor contradiction, but we have to use the terminology contingency. So, a contingency is a statement that is true in some possible case and false in others. And that's it for our video. Thank you so much for listening. I hope you learned something. Ingat kayo and God bless everyone. Bye.